Our next excursion into this problem type is we have the function f of x is equal to a over x minus b. A and b are constants, they're just not known. We need to find those values of a and b. So f of x is a over x minus b. The derivative and the second derivative are given. F prime is negative a over x minus b squared. Second derivative, f double prime, is given to be 2a over x minus b to the third. So we have the derivatives given and computed for us. The question is, do we know what to do with them once we have them? And we have three questions. The first, for what values of a is f decreasing? The second, if a is equal to negative 3, for what values of x is f concave up? And the third, if x is less than b, for what values of a is f concave down? So it's all these ideas, and they're being scrambled them up and juggling them in different sequences. And so let's see if we can go through these. So number one, we want, for what values of a, so we want to find, our final result is going to be find a. We want to know for what values of a is f decreasing. Well, we know if we want f to be decreasing, then that means we want the derivative to be less than 0. If the derivative is less than 0, that's going to cause the function to be decreasing. So, for what values of a is the function decreasing? We want to find the values of a which cause this derivative to be less than 0. So we want the derivative, negative a over x minus b quantity squared, to be less than 0. Now the key is this quantity is getting squared. We have a fraction, and we want it to be less than 0. That is to say, we have a fraction which is negative. And we know the denominator is always positive. Now a person might argue this numerator must always be negative, but that's not the case. If a itself is 4, then we have negative 4, and yes, this numerator is negative. But if a itself is negative 4, or if a itself is negative 10, suppose a is negative 10, then negative 10, that becomes positive, and we have positive divided by positive. So this value would be positive or negative depending upon the specific choice we make for this original coefficient. And our requirement, or what we're being asked to do, is find the values of a which make this expression true. What we do know, and we'll just sort of conceptualize this, we have negative a, we have this expression, this quantity, which is, we've seen, this may be positive, it may be negative, depends upon the particular we choose for a. But we do know this, no matter what happens down here, assuming this function is defined, this is getting squared in the denominator, this is positive. So we have something divided by positive, and we want the answer to be less than 0, or a negative number. Well, when do you have something divided by, when you divide and the answer is negative, means if this is positive, this has to be negative, and vice versa. If the denominator is positive and the total fraction is less than 0, then we know this numerator, the entire numerator, not just a by itself, but the entire numerator must be a negative value, which is to say, this implies that negative a must be less than 0, divide both sides by negative 1, and when you divide by a negative, you must reverse the direction of the inequality, and we have our solution. For what values of a is f decreasing? Any value of a greater than 0 will cause this function to be a decreasing function.